Hi, this is Jason Vaccarella and Corbin Jones, and this is our Project 8 for EN605.715. So we have mounted our Arduino here on top of the drone, and it's connected to the IMU here. This breadboard had adhesive, so we just mounted it to this portion of the drone here, and then it's connected to the Raspberry Pi via USB. We just wanted to give an update first on the state of our drone as far as being able to fly goes. We've been working on it, and we've kind of found a couple issues. The major one being, if you go around here, I could show most of or 3 of the 4 are level. The arms are level. I'll go around. But as you can see, this one is off, and also this one tends to be off as well. So we think that's the main cause because it usually flips this way. So meaning these two are the cause or we believe that's the cause. So we're going to try and fix that. But if we are not able to, this will be our submission, and hopefully we'll get that working for next time as well. But we think the cause is mainly the plate here. We had to really move the arms into place to screw down. So we think it maybe is causing some internal torque that's causing the ends here to be rotated slightly. That being said, we're going to move on and show you that we can still get the IMU readings via the Raspberry Pi over Wi-Fi, and Corbin's going to go through that.
Awesome. So our IMU sensor is connected to our Raspberry Pi, and on our Raspberry Pi we have the Arduino Sketch IDE installed. We have some code that we adapted from the tutorial documents here, and we adapted it to use the xtask create function from the free RTOS library. And so the task that it spins up reads the pitch, yaw, and roll measurements from the IMU sensor. And so we are actually able to run this through the terminal from our host machine, which is SSH'd in as our Tor user into the Raspberry Pi. And so we can first upload the code. We're going to upload this task sensor or task IMU sensor.ini file over the dev TTY ACM0 port, which is the USB that our Arduino is connected to via the Raspberry Pi. So you can see that our code is uploading here, and it's going to take just a second to upload the code from the Raspberry Pi to the Arduino. Perfect. So once our code has been successfully verified, and now it's been uploaded, we are going to run these 2 commands to be able to see the serial monitor output, so we can cat this file. And once we cat that file, we'll have live measurements coming in every second that show us our pitch, our roll, and our yaw for the drone.
And I'm going to, so the way it is this is yaw, so this axis is yaw, this is pitch, so this axis is pitch, and roll is this axis, so it'll be like this. So the first one we'll see is if you look at the yaw measurements.
Hold on, Ark. I'm going to rerun our sensor real quick. Okay.
Sweet. So I'm going to I'm going to rotate the yaw direction first, and you should be able to see changes there. Yeah. So I'm just rotating it this way, and that's changing. And we can go the other way as well, and it should loop around. Yeah. Okay. Now the next one I'm going to do is pitch. So I'm going to pitch up here, and that'll be,
See the pitch increasing in
So that's
corresponding use.
I don't want that to fall. Yeah, so that goes up, and then we can also go the other way, down. And the pitch gets negative. And the last one is roll. So I'm going to roll to the left here, or I guess counterclockwise would be the way.
So we see the roll increasing.
And then I'm going to go clockwise.
We see the roll decreasing.
Yep. And that's it for the IMU for Project 8. Thank you.